Hello and welcome everyone. My name is Peter Robinson. This is the Ethereum Engineering Group Meetup. And today we've got Sam who's going to talk about the new Ethereum execution layer spec, PySpec. So Sam, why don't you introduce yourself and give us a bit of a very quick introduction.
Sure, I can do that. So I'm Sam. I work at the EF, and I will get a little bit into that later on. Um, I will warn everybody right off the bat that I am terrible at giving presentations. So if I'm talking too fast or anything like that, please let me know. If you have any questions, just interrupt. I won't have chat open, so just yell at me. And with that, I'd like to introduce the Ethereum execution layer specification. It's kind of a spiritual successor to the Ethereum yellow paper, except this one's actually maintained. If you're only going to watch about a minute of this presentation, this is kind of the part you're going to want to know. Today we have, or before today, we have the Ethereum yellow paper, which is kind of a very academic document. It uses a lot of opaque symbols and mathematical notation, and it's not very accessible to programmers. Personally, I got incredibly frustrated trying to use this document back in the day. There was like a programming competition that Paradigm put on, and that kind of inspired this whole thing, was trying to understand the internals of the EVM. Right now, we have Eels, or the Ethereum execution layer specification. And it's a Python application, basically just a regular Python program, nothing fancy about it, that implements a reference implementation for the Ethereum protocol. It's not the entire Ethereum client. There's a bunch of stuff that it doesn't cover, and I'll get into that a little bit later. But this is kind of an example of what the jump instruction looks like. And if we look at the previous slide here, this 152 formula is the jump instruction in the Ethereum yellow paper notation. Each instruction is split into chunks here. We have stack manipulation, then gas calculation, the actual implementation of the operation, and then modifying the program counter. We also have an example of what a data structure looks like in Eels. It's just a regular Python class, fully type annotated. And if you're familiar with Python at all, it's going to be very easy to read. Where we're going with the Ethereum execution layer specification, or Eels, is we want to build a snapshot of Ethereum at each hard fork, and we want to be able to highlight the differences between each hard fork. That's kind of this left-hand side over here. And then further, we want to make it easier to write EIPs, or Ethereum improvement proposals. We want people to be able to take snippets of Eels, make changes to it to implement their EIPs, and then include that directly in line in their document. And that's going to make it so much easier for people to actually work on the Ethereum protocol and clients. A little bit about me. So my name's Sam Wilson. You can find me at sam_wilson at movie.monster if you use Mastodon, or you can find me on GitHub at github.com/samwilson, no O. I have kind of a varied history in software development. I started at Solace, went to Akamai doing CDN type stuff, moved to Consensus, then Consensus Mesh, and now I'm at the Ethereum Foundation, if you're ever curious where to find me. I work on 3 major projects at the Ethereum Foundation, and I'm going to take this opportunity to shill all 3 of them. I work on all wallet devs, I'm an EIP editor, and obviously I maintain Eels as well. So All Wallet Devs is a Discord server for wallet-related discussion. We have monthly video calls and demos, and we have over 40 wallets. Come check us out. It's a fun time. I also do EIP editing. I do biweekly office hours. They're taking 2 weeks off, so end of October would probably be the next one. And I also maintain a linting tool, EIPW, that is a great introduction to Rust if you want a project to work on. And the reason you're all here, I hope, is the Ethereum execution layer specification, and we're going to start talking about that shortly. So what is an Ethereum execution layer specification? It's a Python reference implementation of most of an Ethereum client. There are a lot of things we don't cover, like the peer-to-peer networking layer. We don't actually cover fork choice, but we do cover pretty much everything else. In fact, you can take Eels and you can pair it up with a regular production client, and Eels can sync or can't sync, I got to be careful with my words here. It can follow the chain. It can verify that all of the blocks are correct. So we have two other people that work on the project full time. We have Guru Prasad Kamath and Peter Davies. You can find them on Twitter and GitHub as well. Unfortunately, this is a terrible time slot for them, so they couldn't make it. But yeah, there are a lot of other contributors that we've also had on the project. Voith and Somu were previous full-time contributors. Light Client or Matt was also pretty instrumental in getting this project set up. And we've had a ton of other contributors over the year. There's also a Poapp or Poapp. I don't know how to pronounce it. I think it's Poapp. If any of you are motivated by that kind of on-chain reward, you can get one. It has a cute eel on it. Come contribute. We are looking for people who are particularly good at CSS and front-end design. We're building our own documentation tools, and none of us are particularly skilled at making things look good. So if that's your talent, reach out to me, and we can get you started on working on that. Okay, so let's talk about what we're replacing, where we're coming from, and kind of the motivations for why we're building Eels in the first place. So the yellow paper itself was was started in around 2014 by Gavin Wood. It was most recently maintained by Nick Savers, and it has contributions from people all over the world. It's released under Creative Commons by attribution, which I have to mention because I'm using snippets of the yellow paper in this presentation. So now, let's go through really, really quickly what the yellow paper is. And I am warning you now, I am incredibly biased against the yellow paper. So take everything I say with a grain of salt. So first we start off with the background section. So this is probably one of the nicest things about the yellow paper's format. It has a lot of context, and it's written in a narrative style. So you can follow the yellow paper from the beginning to the end, and it actually describes in a linear way how Ethereum works. And that's a super useful property of the yellow paper that I kind of want to point out. It's nice. And Eels doesn't do this yet, but it's something we're going to be aiming for. Then we get into actually some technical definitions here. So we define what a blockchain is. Now, if I understand the yellow paper's notation correctly, Formula 1 here is saying the state at time plus 1 is equal to the state at the current time modified with a set of transactions through the state transition function. So that's kind of what Ethereum is. It's a virtual machine that takes a bunch of data, applies a function to it, and creates new data. It also goes into describe kind of what mining is, and we have some more formulas here that describe other things that I'm not going to get into. It also describes the fork choice rule. So fork choice is, you're all like Ethereum people, so you probably know this already, but the fork choice is picking which chain to follow. It's agreeing on what the canonical head of the chain is. The yellow paper does describe this. Eels kind of ignores this part, but that's fine because we went to proof of stake anyways. So we do talk about state as well. So the yellow paper goes into details about what the world state is. And here's another place where it does a really good job of describing things. It tells you exactly and gives very descriptive names for exactly what each component of the world state is. You have the nonce, you have the balance, you have the storage root, code hash. All of these are great names that the yellow paper assigns to them and then completely replaces with, I believe that's sigma square bracket alpha subscript n, which is a completely opaque name that absolutely does not tell you what the nonce is. And that's kind of an example of what I really dislike about the yellow paper. It takes these terms that we've all agreed on and turns them into alphabet soup that makes it really hard to follow. We have two more examples of formulas here. We have the equivalence between the state and the transformation, like this is how it defines accessing key value pairs inside the state. And then we have the collapse function, which is given in formula 8 here. The yellow paper further goes on to describe what a transaction is. This all makes sense. We all know what a blockchain is. We have nonces and gas prices and gas limits. Again, we have these great names that exist in the yellow paper right here, and then they're replaced with this lovely T subscript N, T subscript P, T subscript G, T subscript T, alphabet soup again. So if you're an academic, you probably understand this a lot more. You're probably a lot more used to this notation. But as a programmer, these kind of formulas are incredibly opaque. Again, I just want to highlight the yellow paper doing a very good job of explaining everything and then turning it into alphabet soup again. And we have the rest of the yellow paper. We have, the gas definition. We have how contracts work. We have the entire virtual machine, RLP, modified Merkle-Patricia trees, a list of all the pre-compiles and EVM instructions. You all know blockchains. You get the idea. You know what's in the yellow paper. Now I want to talk about the problems that the yellow paper has. I've already kind of hinted at them, but I want to make it more explicit here. All of these formulas were on previous slides. I have no idea what they were, and I just read them to you. This is the kind of problem that I want to fix. I want to make the yellow paper more accessible to programmers. Programmers are the ones who need to understand the yellow paper the most. When you're sitting down to write a client or make a change or analyze how Ethereum works, you're going to be a programmer, and programmers need to understand this stuff. As kind of an example, core EIPs, which is where changes to Ethereum are proposed, rarely use the notation from the yellow paper. Instead, they spend a whole bunch of time redefining chunks of how Ethereum works in Python pseudocode. Or you'll end up with things like, I'm introducing a new variable that has the same scope as the already existing piece, like program counter variable. And these kind of workarounds where we don't have a spec that people agree on are very annoying when you're trying to read EIPs. So next problem with the yellow paper is that it's unmaintained. It's very hard to find people who are interested in writing LaTeX, which is the language the yellow paper is written in. It hasn't been updated since Berlin, and we've had 5 hard forks since then. Some of them are difficulty bomb adjustments, but there's still 5 forks that haven't been covered by the yellow paper. And the last notable content change was in July 13th of 2022. That's been a year of changes that just hasn't been applied to the yellow paper. It's untestable. So the yellow paper is written in human language, mostly human language. And there's no way to test the specification. You can't write a unit test to make sure that what the yellow paper describes is what you want it to describe. And you can't use the yellow paper to fill tests. So if you aren't familiar, there's a corpus of tests that are defined, and then you run them against a client to generate the output. And then you can use this to verify other clients to make sure they behave the same way. You can't do that with the yellow paper. The yellow paper is English. You can't execute it. But I want to, give the yellow paper as much, benefit as I can. It's very succinct. You can express things in the yellow paper with this complex notation they have in 10 words. You can compress the entirety of Ethereum down into maybe 100 formulas, whereas Eels is huge. We have, tens of thousands, probably about 10,000 lines of code. It's significantly more than the yellow paper. The yellow paper is also formal. If you follow the yellow paper and you interpret it correctly, you're pretty much guaranteed to get a functioning client. That's not necessarily true with Eels. It's a reference implementation, which is good but different. And kind of further on that note, the yellow paper doesn't specify algorithms. So the yellow paper can just state, the block number, the 10 blocks after block 1000 have to contain the DAO fork in the extra data field, where Eels actually has to come up with a particular algorithm and iterate through the blocks, and those kind of algorithms or choice of algorithms can leak into production clients, and that's not something we want. But I'll talk a little bit more. I'll talk a little bit more about that later. Eels was created in May of 2021 by Consensus's Quilt team. So that's myself, Matt Garnett, and Ansgar. And it's kind of been taken over by the Eels team at the Ethereum Foundation. We also have contributions from people around the world, but we have a more permissive license. We use Creative Commons 0, and that's because we want people to be free to use this code in their clients and copy it. We just want it to be open for everybody. So why are we creating Eels? So I'm interested in it because I get incredibly violently frustrated every time I try to read the yellow paper. There's also no current snapshot of Ethereum. So what do I mean by this? So if you want to look at, let's say, Shanghai, right? And you want to see what the specification is for Shanghai, you need to look at the yellow paper for the fork that came before Shanghai, and then look at a list of the EIPs that are being applied to that yellow paper. And that's the only way you can really build a picture of what's going on in the next hard fork. You can't, there's no yellow paper until months after the fact, or years now, of what the current state of Ethereum is. Eels is going to solve that. The output from Eels at every hard fork is a complete specification of that hard fork. We also want to be more accessible to programmers. Python is a very, very popular programming language, and it's very easy to read even for people who aren't familiar with programming with it specifically. We also want the same document that specifies Ethereum to be able to fill automated tests for it. We want to be able to take the exact content of an EIP and fill a test for that EIP instead of having to say, you know, write the EIP, implement it in Geth or Reth, and then generate the test with that client. So now I'm going to give you a blazingly fast tour of Eels itself. We're going to go through the same kind of structure that we did going through the yellow paper, but instead we're going to be looking at screenshots of the Eels. We don't have a background section. That's not done yet. We're actually missing a lot of the English documentation. But we do organize our code a little bit differently. So for each hard fork on Ethereum, we have a folder in our source repository, and that folder contains the entire specification for that fork. That means there's a lot of duplication. You'll find the exact same code in Arrow Glacier, in Berlin, in Constantinople, with tiny little tweaks. And the reason why we do that is so that you can look at Constantinople or look at Shanghai, and you will know exactly what's in that fork. There's no branches, there's no configuration options. It's what you see is what you get. It's that simple. We do have some tooling to help with that, and you know, I'll show that again later. So here's kind of our definition of what a blockchain is. For us, a blockchain is a list of blocks, a state, and a chain ID, because we do support some testnets. And then we have our state transition function. It's a lot more verbose than the one line that the yellow paper uses to represent the state transition function, but this is also a lot more readable for programmers. You can look at this, be familiar with Python, and you know that the first step, the first operation you do is you validate the block header. Then you look at the omers and you validate those. It's regular Python. I can't stress that enough. It's this simple to read and write Eels. We have our own, you know, fork choice, sort of. We do validate the proof of work, but again, we assume that we only receive blocks from the canonical chain. We don't support reorgs, which is kind of a shortcut we take, but I think that's fine for understanding Ethereum. We also have our own state. It's an opaque class that supports all of these functions. And we have our transaction definition. They're regular Python classes. with names and understandable contents. You know that the transaction class here is either a legacy transaction or an access list transaction, and we try to keep everything understandable, everything readable, and that's kind of the focus we're going for. We don't want to get into the same situation that we did with the yellow paper where things are opaque. Here's an example of what our blocks look like. You can see all of the fields that are in the block. We have the exact same things from the yellow paper, but we don't replace them with opaque symbols. We keep them English and we keep them readable. That's not to say there aren't problems with Eels. It does require Python knowledge. If you want to modify or add your EIP or anything like that, you need to know Python. And because it's an implementation and not just a specification, it requires specific algorithm choices. We try to choose the simplest algorithm, and oftentimes it ends up horribly inefficient. But those kind of choices can make their way into production clients, and that's definitely a downside for this. It's also a lot more verbose. Like I mentioned, we have tens of thousands of lines of code compared to the yellow paper's 1,000 words. It's also a lot less accessible to academics. We've had some complaints from people who really like the yellow paper and how they're used to it. And if we put all this time into Eels, the yellow paper is going to fall by the wayside. But I think the benefits are pretty clear. We can look at these and we know that this is defining the state transition function. We know that this blob is an account. We know, a transaction is a transaction, and we know that there is a function called getStorage. It takes more characters to express, but it's also more clear in the long term. Core EIPs already use Python. Oftentimes they'll define half of the state transition function in their EIP and then make a small change to it. Now they'll literally be able to use Python as opposed to pseudocode. It's also a lot more accessible. That's kind of the goal we're going for. It's maintained. It's much easier to find a Python programmer than it is to find somebody who understands the yellow paper. We were implemented all the way up to Paris, and we actually have some of the Shanghai EIPs implemented by the Shanghai EIP authors, which is great. That means it's easy enough for people to come and contribute. And again, that's really the goal. We want this to be the most accessible, the most readable, the most approachable kind of place for Ethereum specifications. We want anybody to be able to participate. Eels is testable. We passed the entire Ethereum test suite, and we can fill tests for production clients. That's been a goal of ours from the beginning, and we can do it. It's a little clunky, honestly, but it works. Yeah, so sorry, apparently I've rushed through this. I'm terribly sorry about that. But what have we been doing for a year? We've been working on a lot of cool stuff. Diffs is kind of a big one. So we want to be able to take, I mentioned that every single fork is its own copy of the Ethereum protocol or specification. That's great if you're just reading the specification, but if you're somebody implementing a client and you want to just know what's changed between two forks, you need these kind of diffs. So we've been building our own tooling to be able to render these changes between forks. We're also participating in fuzzing. That's kind of our next goal that we've been working on. The pull requests are live right now. I just couldn't find a good picture of what fuzzing looks like, so I kind of just went with the missing image icon. But yeah, if you aren't aware, there's kind of a test suite that runs all of the clients and generates inputs for them, semi-randomly, and then make sure that they create the same output. And we're going to be able to participate in that. So that's one extra client that can find problems in other clients. And we're implemented very, very differently than other production clients. We're completely different. So it's going to give a new perspective, a new way for fuzzers to kind of explore. And I think that's going to be a useful tool. So I have some resources that might be interesting for the people attending this call. We have, I gave a workshop a couple of weeks ago about adding an EVM instruction to Eels. So we go through like what it looks like to add the opcode, implement the opcode, teach the instructor or the interpreter how to teach the interpreter how to run the opcode. And then Peter actually gave us a nice talk about the execution layer specifications, and then we have a link to the specifications themselves. Unfortunately, I went way too quickly, so that's about it for me. But yeah, does anybody have any questions? Anybody want to like talk about it? I can also fill time by, running through like a tour of Eels if anybody's interested in that. But yeah, that's it for me.
So does anyone have any questions at this point?
Yeah, I can probably ask a question or two, at least. Hey Sam, thanks. Cool talk. So just one question on that, on the thing you showed us, the diff functionality between forks, which I think is really useful because when you just have all of the code for a fork in one place, it's very hard to understand the differences. So one thing would be really handy would be if it can be annotated with the EIP that it corresponds to, right? That'd be really cool. Is that something you're thinking about?
Yeah, so we've thought about that quite a bit. And kind of the intersection between Eels and governance has been a very contentious place. Um, so annotating it with the EIP would be very difficult because then we'd have to track each EIP as its own directory and have a copy of the entire source tree for that. And that would be kind of difficult.
You could
But
try to embed it with comments into the code, right? If you had a comment at the
yeah,
point of difference.
yeah, you could do something like that. But you'd probably run into issues where several EIPs would modify the same thing and they'd stack on top of each other. I don't know. It gets a little messy. But we are thinking about it. One thing we want to add is like a get blame style annotation so you can see the last fork each line was changed at, which I think would be pretty useful.
Yeah.
Um, yeah.
And the other thing that she like, I've actually spent a bit of time looking at Eels as it happens, and also the yellow paper. One of the things that I do like about the yellow paper is that I can actually hold it and, literally flick through it quite easily. Whereas I find looking through code, even though it's not a huge amount of code for one fork, say, still can be difficult to answer questions like, where is the bit of code that does this thing? Trying to find or answer those questions I find quite difficult, and I just end up searching through the code, not endlessly, but it takes quite a lot of time, I feel. And it would be almost nice if there was a sort of printable version, or even if it was just a cut down with comments and so on. Is that something that you're interested in?
Yeah, so the end goal of this is to have something akin to literate programming.
Right. Yeah.
So we would very much intersperse comments and everything. And we've been internally calling it like narrative style documentation, where you
Okay.
go to the like very first page and then if you just read, you'll eventually end up at the end of the specification and you'll get through all of the content. That is kind of the next big thing after we get the documentation tooling done. And I think that's
Cool.
going to be a huge benefit.
Yeah. Cool. Awesome. Awesome. Cool.
So my thought, so I've only looked at Eels once, and I think it was about probably almost a year ago, or maybe it was 6 months ago, I don't know. But anyway, and I remember getting very confused just trying to work out stuff. So your offer of doing let's just open up the directory or click on the link and then, I don't know, say just something really simple like, all right, let's find where the add opcode is or something like that, would be really interesting. But before you do that, someone, Karma, has put a comment in the chat, and their question is Eels complete? And is there any area where you are looking for contributions? How's that? You might have a contributor.
That's exciting. So Eels is complete, and I'm going to say that in air quotes, in the sense that everything is implemented all the way up to Paris. As far as I'm aware, we can sync. If you choose random blocks, provide the pre-state, we can execute those blocks. That should be fine. But we're not done in the sense that we don't have the narrative documentation. Um, there's a lot of organization that we need to do, and we're also working on improving our documentation rendering tools. So we're looking for contributions in like CSS, HTML, and anybody, if you're just good at Python, that would be lovely just to come through and take a look at it. Um, but yeah, we're basically done the specification part all the way up to Paris.
Mhm. Yeah. Okay. Oh, and
There's another question here. For upcoming EIPs, is there any way to check how they interact? And that is an excellent question. So that's kind of what I was referring to when I said the intersection between eels and governance is a little bit fuzzy. And that's because we don't have a good way of keeping, because EIPs are developed independently from a fork, and then eventually they get chosen to be included into a fork. So we're kind of imagining a world where each EIP is maintained in a branch, and then once it's moved into the considered for inclusion or CFI state, then that branch would get merged into the fork plus one kind of directory. Um, and that's when you'll find the interaction problems. And hopefully that'll be early enough to fix them, but we haven't actually tried it yet, so we don't know.
yeah, so I guess the Eels needs to be up to date with the latest fork before you can really start doing that, because otherwise you'd be trying to do a pull request based on what will be, by the time you've updated Eels, based on an old fork, wouldn't it?
Exactly. Yeah. So there's going to be like a fork. So like imagine a fork gets released. Let's say what's the next one? Cancun. Cancun gets released, and then there's going to be a period where Eels will do any refactoring, any maintenance that we have to do. And then we'll freeze Eels, and then EIP authors will be able to make their changes on top of it. And then once we decide the contents for Cancun plus one, all of that will get merged into a branch, and then that's when we have the specification for Cancun or Cancun plus one.
Sounds good. Sounds good. So if you've got even just 5 minutes, I think it'd be really interesting if you were to share, like, go into the website for it, and just so we can explore. I mean, even as I said, something simple like, say, the add op code. How do you locate that, and just trying to interpret it would be really interesting.
Sure, I can do that. So I will warn you. Well, I'm going to do it twice. So we have two different documentation tools that we're transitioning between right now. So I'll do it once with the old one and once with the new one, and it's a little different. Let me just share this again. There we go. So this is the current specification or documentation tool. It's rendered with Sphinx. If you're familiar with Python, you probably know Sphinx. So the easiest way to find anything in here is to go through the hard fork index. Let's say we want to look at the latest, which would be Shanghai. So we get a list of all of the modules, and right away you can see kind of like the VM section here. That's where all of those are. And they're divided up in the same way as the yellow paper has them divided. So add will be in the arithmetic section, and then you'll find the add function, and here's your implementation of add.
Yeah, seems easy. I'm
When you know how to do it, yeah.
and I think, yeah, I mean, and who knows? I know you were saying you were going to put a more essentially English words at the start of it, more of an introduction at the start, and maybe having that how to use this would be something that would be useful, because I'm sure I just got confused right at the start and then thought, oh, look, I'll just look it up in the yellow paper. I know what I'm doing there. All right, so that's the old tool. What's the new tool look like?
Sure. So we ended up running into some limitations with Sphinx, and we ended up building our own documentation tool. And this is the tool that we need help with. As you can see, it looks very, very bare bones. but you can navigate through the source tree in the same way that the source files are organized. So we'll go through the VM and then through the instructions, arithmetic, and we're here in the arithmetic section. And here's the implementation of add. Now, the nice thing about this, and the reason why this is a much nicer tool, is you can actually click through to the definitions of functions inside of the code blocks, which makes navigation significantly easier than what we were doing with Sphinx. And that's why we're switching. But we also need, like I said, help making this look pretty. We also do have diffs. So the DAO fork is my favorite example of a fork with diffs. Sorry. So the DAO fork was a irregular state transition. So at the beginning of the DAO fork, the first 10 might not be 10. The first n blocks had to be special to signal that everybody had upgraded to the correct version of Ethereum. So you can actually see, you can see here, there's apply DAO. So I'll switch to that in a second. But you can see right here where when Tangerine Whistle came out, the DAO fork code is just removed here, and you can see it being deleted. And then you can actually see the exactly what was removed and what was added between the forks. So that's kind of the tooling we're building here.
Yeah, that'll be great when that comes out. So yeah, hopefully lots of people will help you out and make that really good, because I think, as you say, being able to click on things and go to their source is going to be really helpful. Yeah.
Yeah, it's just like navigating through code is much harder than navigating through the yellow paper. So we want to make it as easy as possible.
Yeah. All right, and that was available based on your GitHub website. So that's cool. So we can even watch it as it improves with time. All right. Well, look, Sam, thank you for delivering. Oh, just a sec. We might have some questions in here. Let's see. I think Python works well as a sort of executable pseudocode that most programmers can make sense of. But what about oddities like slotted freezable?
Yes. So there are some features of the spec that are, so obviously our primary goal is to be readable, but sometimes we want something like being able to sync mainnet. And to get that feature, we need to kind of clutter up the spec a little bit. So slotted freezable is a Python decorator, which is probably one of the fancier things we use, that makes it so that that class can't be changed except in a very specific place.
Mm-hmm.
There's like the state try, and we have a poorly performing version that just uses a Python dictionary, but we also have a highly optimized version that uses libmdbx, and we swap them out if you're trying to sync mainnet, and slotted freezable lets you do that. So there's a few Python things in there that we try to hide as much as possible.
Yeah, Nicolay has said, for older forks, is the fork choice algorithm included? You mentioned it wasn't, if I heard correctly.
Right. So we don't implement like rolling back blocks. So we assume that every block we receive is from the canonical chain. And the only reason we do that is to keep the state implementation simple enough to understand. But yeah, in a production client, you have to be able to roll back blocks and apply different ones. So
yeah. All right. Look, thank you for a great talk. I think a shortish talk with a lot of questions is a very good talk. Certainly helps get everyone thinking. So thank you very much for your time this evening for you.
Hey, thanks for having me. I always appreciate the opportunity to talk about eels.
Yep. All right. Well, thank you, and see everyone in 2 more weeks' time. Bye-bye.
See ya.